Solve the following equation for x. So the equation that we want to solve is log 2 of x all squared equals 6 log 2 of x minus 9. And now if we notice where the squared position is here, this indicates to us that because we've got a log 2 of x all squared term, a log 2 of x term, and a constant, that it may in fact be a quadratic that's hidden inside our log equation. So what we're going to start by doing is we're going to let capital A equal log 2 of x. Therefore, we can rewrite our equation as a squared is equal to 6a minus 9. Now that we can see the quadratic that exists behind the scenes in this equation, we can use our techniques of solving quadratics to help solve this equation. So one general thing that we'll do is get all the terms on one side so that we've got an equation equal to 0, and that means we can use the null factor law with our quadratic. So I'm going to start by subtracting 6a and adding 9 to both sides. So that means that our equation can be written as a squared minus 6a plus 9 is equal to 0. Now the purpose for doing that is we can factorize the trinomial on the left hand side, and you can recognize potentially that this is a perfect square. So this can be written as a minus 3 all squared is equal to 0. Using the null factor law, we can then say that a minus 3 could equal 0, and adding 3 to both sides of this equation will allow us to find a by itself, and we find that a is equal to 3. However, we know that a is simply log 2 of x, therefore the equation we're solving is log 2 of x is equal to 3. Now, as x is the part inside the log, we can use an equivalent statement to find what x is equal to. So in our equivalent statement, the base 2 remains the base, and this equals 3 becomes the power, and that is equal to the part inside the log, which is x. Therefore, x is equal to 2 to the power of 3, which is simply 8. So that is the solution to this equation.